I'm going to talk to you about application security testing tools. So who am I? Kevin Feely, work at Aspect Security. This is my 6th year there. I'm the lead of Aspect Security Automation Division. So basically my focus is on any type of tool, streamlining processes, and automation in general. And I like to think that, I have a computer science degree and an MBA, so I like to think that I can kind of bridge the gap between technology and business. So kind of on the heels of that, this presentation is not super technical. So if you're really techie, I apologize for that. It's a little bit higher level, but I think it's pretty interesting. So the key takeaways here are the differences between static analysis, dynamic analysis, and interactive analysis, tips for choosing the right tools, and tips for choosing the right integration points. So real quick, just to get a quick understanding, how many people are pretty familiar with SAST, DAST, and IAST, all three? Yeah, how about one of the two? How many people are actually using these tools? Okay, and how many people are kind of decision makers in your security realm to decide which tools people will be using? All right, great, so hopefully this will be pretty useful. So first, why do we need tools? Well, more applications keep being written every day, obviously. They're not going to stop. More web applications, mobile applications, and applications for other platforms. And vulnerabilities continue to be introduced into those applications. A lot of people here have talked about the old vulnerabilities that have been around for decades are still being written into new applications, as well as new vulnerabilities being discovered every day. And AppSec budgets really aren't changing very much, unfortunately. AppSec budgets make up a very small percentage of the overall security budget in most organizations. So we need to find a way to scale our AppSec, and we need to be better, we need to be more efficient. Tools, I think, are at least part of that answer. So here's a quick overview of the types of application security testing tools. So I'll go through this pretty quickly. It seemed like people had a pretty good understanding. So on the left, we have dynamic analysis, or DAST. Right, that's black box testing. That's really simulating what a hacker would do if they're attacking your website. It's sending HTTP requests, getting HTTP responses back, and trying to kind of break the live running website. Then there's static analysis, which is usually called white box testing. And that's can analyze the source code of an application, or it might analyze the compiled binaries or compiled bytecode of an application to look for vulnerabilities there. So you're going to find a lot of best practices here, and it's simulating the running of an application. And that's an important distinction for static analysis, is that it's static. You're not looking at a running application. You don't need it to actually be running. And then there's IAST. IAST is interesting because it's relatively new. It really showed up about 3 or 4 years ago, and there are lots of different implementations for it. It's kind of a new buzzword, right? So everyone has an IAST solution. But I've kind of broken it up into 2 groups. The first is hybrid analysis, which is usually using both static analysis and dynamic analysis together, correlating the results or using the output from one of those tools as input to another tool to make them better, right? So if you find a vulnerability using your static analysis tool, can you use that information to confirm that there's a real vulnerability by sending that information to your dynamic analysis tool to actually find the exploit, right? And there are a few other different implementations of that. The other side of IAST is instrumentation. So I'm sure many of you heard Jeff Williams speak today. Contrast is one of 2 instrumentation tools on the market. The other, I believe it's pronounced Quodium. Sorry if I'm pronouncing it wrong, but I think it's called Quodium. Those are 2 instrumentation tools. The difference is that instrumentation actually sits in the runtime, right? It's not doing static analysis or dynamic analysis. It's sitting in the runtime and kind of doing both, actually. So it's watching all of your commands being executed. It's watching your HTTP requests, your HTTP responses, sitting in memory. It can see everything, the entire application, right? So if you've ever used a debugger, if you're a developer, that's basically what IAST is, except it's looking for things, not just showing you everything, right? And then on the other side, there's RASP. I'm not really going to talk about RASP. I just put it up there because people often group it in with IAST, or people talk about RAST, which is runtime analysis, very similar. So this is just to kind of clarify. RASP is actual protection. So it's like IAST plus making changes to things in memory to try to protect you. So what's better, a hammer or a screwdriver? Right? What's better, SAST, IAST? It really depends, right? It depends on what the problem is. So kind of a Dr. Who geek. So what's better, a hammer or a sonic screwdriver? Obviously a sonic screwdriver. Some popular AST tool vendors. This is from the Gartner Magic Quadrant. If you're familiar with that, every year Gartner puts out a ton of different documentation, a ton of different research analysis on the industry. And so this is just one of them. This is the one from this year on application security testing. So they go out and they look at all of the application security testing tools on the market and they evaluate them. And they put out this report, which if you're a Gartner subscriber, you can get. And most of these vendors will just buy a bunch of licenses or a bunch of copies, and you can download it for free on most of their websites also. So if you're just starting out and you're looking for a tool and you don't know, who a good vendor is aside from the ones you see at these conferences, going to the Gartner Magic Quadrant is a good place to look. And they have a good list of the feature sets of all of these all of these vendors. But those aren't the only vendors out there. And this is important because the only vendors out there are not the commercial big spend vendors, right? Of course, there's IBM and HP and Veracode and all the other ones, right? Very expensive tools, and they're great and they do their job. But there are other tools, these open source tools, right? You can use PMD or SonarQube, which are typically used as code quality tools, right? So they're not typically used as security tools, but they allow you to write rules that evaluate the code. So you can write security rules, and we've done this for some of our customers, right? So if you're looking to branch out and look at other tools, consider what you have already. Consider what you're already using, and consider at least piloting a new program using free and ideally open source tools. And then you can always move on to other vendors after that. But before contacting a vendor, right, consider which tools are most compatible with your applications. The reason I put this here is because I feel like a lot of the organizations we go to, they already have a tool in mind, right? And the tool is really based on the vendor. So the person who's making the decisions looks at their tool set, their existing tool set, and they say, hey, we already have all of these applications from this big vendor, right? And they'll give us a deal if we get their tool. So you go to that vendor and you say, hey, I'm in the market for a new dynamic analysis tool or a new static analysis tool, or I just need help with my security program. And they come to you and say, oh, we have the answer. It's our tools. Big surprise, right? So first, try to figure out what is the best fit in your organization before going to the big vendors and them selling their own tools to you, right? And then once you have an idea of what's compatible, think about where you want to use the tool. How do you want to use the tool in your SDLC? Everyone's SDLCs are different, and most of these tools can fit into multiple different points in your SDLC. So, think about that before you just buy a tool and then try to stick it in there. I'll talk about that a little more later. So I have some questions here. I'm going to go through the next couple slides to kind of address these. But these are some questions to help you decide which tools are compatible with your organization, with your application portfolio. So the first is language support. So this looks really dark. Is this really dark for you guys too? Sorry, I don't know if I can fix that. No, it's just doing it in my monitor. Sorry. Well, this is showing a handful of tool support for IAST, right? Because IAST is pretty new, so there's not a whole lot of support for it. If you use some pretty common languages, if you use Java, .NET, PHP, Visual Basic, Cold Fusion, and C#, those are the languages up here, then there's an IAST solution for you, right? Either from Contrast or from Quodium. But if you don't use those languages, or if the majority of your applications are not one of those languages, then IAST right now is probably a little too new. Definitely worth exploring in the future, where you can reach out to the vendor and say, hey, is this on your roadmap? I know both vendors are looking to add more language support. But as of right now, there's not a lot of support for more esoteric languages, I'll say. Frameworks are also, this is a really interesting one. For static analysis, if you go to any of the vendors' websites, they all say they support all the major frameworks. And if you talk to the salespeople, they say the same thing. But if you get your application and you scan it, you may find that they support some of the features of different frameworks. And we've run into this several times with different customers who use frameworks in different ways than the vendors expected. So we go and scan their applications with a static analysis tool, and we get very confusing results. Right? They don't find things, they have false positives, or they just break down. And we go to the vendor and we say, hey, what about struts 2? You say you support it, but it looks like you're not getting any data flow through any of the struts 2 code. And they say, oh, well, we didn't think people would use it this way. And so they need to make enhancements. So I guess my point is, I'm not saying they're lying, right? They do support them, but maybe only certain features, and you may or may not be using those features. So before you go and invest in a tool, try to pilot it on your applications, try to get a demo of it in the way that you would use it, confirm in some way that your applications are actually covered. And JavaScript is the same thing for dynamic analysis, right? All of the vendors say they fully support JavaScript, but a lot of them don't. They break down when trying to spider applications that use JavaScript for navigation. They can't find DOM-based XSS. And these are things that are really important. If your applications use JavaScript for most of your navigation, either the dash tool might not work at all, or you may need to spend a lot of time upfront teaching the dash tool exactly how your navigation works. And that you just may not expect that. So something to consider. Different security controls, right? If your applications all use their own security controls for authentication, access control, and everything else, then static analysis tools and interactive analysis tools, those tool sets are really rule-based, right? They go through all of the code or through the running application, and they look at the APIs being invoked, and they make a decision based on that API. If they don't recognize that API, they can't make a really good decision, right? So if you use certain applications for or a certain library for validation, and that library isn't part of your vendor's rule set, well then then the tool is going to think there's no validation happening when there actually is. You're going to have to write custom rules for that. Not a problem if you only have 1 or 2 or 3 applications, but when you're talking about all of your applications, hundreds of applications across your organization, that's a lot of work, right? So if you use common components, if you say you have to use a SAPI, this method of a SAPI when you're outputting coding into HTML, it becomes a lot easier. You write one rule and it covers all of your applications or many of your applications. But if you don't, it can be a lot harder, a lot more work up front. Test case coverage is another one for interactive analysis. Interactive analysis is very much based on executing parts of the application, right? So if you don't execute a particular part of the application, same with dynamic analysis, then the tool doesn't know anything about that application. Right? That's different from static analysis, which just executes all of the paths it can find. Right? But dynamic and interactive analysis can only find vulnerabilities in the code that's actually executed. So if you don't have test cases, a lot of times you're not going to find vulnerabilities in code. It's not covered by those test cases. So certain tools, this isn't as much of an issue for. A lot of the dynamic analysis tools drive themselves, kind of, right? They spider, and then they look for vulnerabilities within those spider pages. Most of the, or let me say contrast in particular, for interactive analysis doesn't do that. It relies on you to have test cases to drive the application, and then it looks through the parts of the application that you have covered. Sorry. So false positives and false negatives are another one, right? If you guys have run static analysis tools on your applications, the first time I did it, I was shocked, right? You run a big vendor static analysis tool on an application that's 500,000 lines of code, and you get 10,000 findings back. What do you do with that information, right? Like most of these are false positives. And then there are other things that are not being found. Those are false negatives, right? False positives are things that the tool says is an issue and actually isn't. False negatives are things that the tool says are not issues, right? It just doesn't point them out, but they are actual vulnerabilities. So you need some way to handle this, and that's either going to be a manual review, And that's difficult because, again, your budgets are probably not moving up very much. And so you don't have the resources to go through all of these findings manually. Or you need to apply really strict filters to say, only show me. We did this with a customer. We said, all right, you don't want any false, but they wanted no false positives. They also didn't want to write any custom rules, right? So no tool configuration at all, just out of the box. We want to use this tool and get all the best results we can. So we deployed the tool actually in a continuous integration environment. So we deployed it in a continuous integration environment. I'll explain that in a little bit. And then scanned 20 applications just to test, right? And we applied the filters that we wanted, that they wanted, right? Which were only cross-site scripting, only SQL injection, and only command injection or OS injection. And only if the tool was really confident that it was a real vulnerability. That's really, really limiting really strict filters. So across 20 applications, right, if we had scanned these on their own, we would have got, what, 200,000 findings, right? Applying these filters across 20 applications, 0 findings. So what value does that add, right? If you get all of these false positives and give them to developers, the developers are going to think you're not adding any value at all to them, right, as a security team. But if you're also applying very strict filters and the developers get no findings, then you're not adding value to anyone. You might as well not run the tool. So you need to have some sort of solution if you're looking at static analysis. Some additional considerations in general, evaluating third-party libraries, right? So static analysis usually doesn't go through libraries at all, right? Some vendors' solutions do, but most of them don't. They just get and they look at the method signature and they kind of go through it. And they use the markup, the rules that they've created to say that this method signature is causing a vulnerability or it's not, right? So it's important to know if that's important to you, that you need to look at third-party libraries. Vulnerable dependencies, right? Known CVEs. Some vendors will look at those, right? It'll look at your entire application, the source code as well as all of the libraries you're using and say, hey, you're using this library which is 10 years old and has these known vulnerabilities associated with it, so you should either change and use a different library or at least upgrade to a newer one, right? SaaS versus product. So some vendors, again, you upload your code to them. They do their own work, right, which has some benefits. They scan the application on their own, or they reach out to your network and scan your application running. One of the benefits is that you typically get very few or no false positives because they review all the findings for you. But there are some drawbacks to security as a service also, versus the product where you have it in-house. But you have to do all the work, but you're in full control. Everything stays within your network. So then there's cost. Obviously, I prefer to start with the free tools. I think it's, in general, a better option. You can usually build off of them. Most of them are extensible, at least. So if they don't have the features you want, you can add features. And even still, they're great for proof of concepts and pilots of new automation programs. And then there's the SDLC integration points, and I have several slides about this. So that's a pool table, right? So would you go out and you see a sweet deal on a pool table, right? Awesome pool table, 50 bucks. Are you going to go and buy that pool table and bring it home and see, hey, where in my house can I put this pool table? Yeah. Well, maybe it's 50 bucks, but it's probably going to end up in the backyard, right? I don't have room for a pool table unless I move my couch out of my living room, right? So you don't treat your tools that way. Don't go out and buy a tool because it sounds great and then try to shove it in wherever you can fit it in your life cycle. Right? It's not going to work out too well. So the best place for a tool really depends on the SDLC you're using. Again, I'll talk about that. So most tools have multiple integration points, and someone said yesterday they use the term sprinkle security throughout the SDLC, and I really like that. So I'm going to say it all the time now. Sprinkle security throughout the SDLC. I like to, a little bit everywhere instead of all at one point. So if you're using waterfall processes, I get the feeling that most people here are not, right? There's a lot of DevOps talks and everyone seems to be involved in that. So I'm guessing more people are agile. But if you're using waterfall processes, you could stick tools still in development. You could stick them in QA. Most people are just using them at security testing. You're using them as gates to elevate your applications into production, right? It slows things down. I mean, it's the definition of waterfall. It slows things down. It's just not really adding a whole lot of value. Most of the organizations we see doing this, right, they say your application can't go to production until we do a security review and we look at the findings, we'll give you the findings. If there are issues, you'll fix them, and then you'll come back, and then we'll move you to production. That never happens, right? The development team says, we're on a deadline, we need to get this team in production. They get a risk-based decision. The application goes into production with the vulnerabilities anyway, right? So that's what's happening. So it's not really that valuable. But you can stick it in development, you can stick it in QA. So in development, most of these tools have IDE plugins, at least if you're using common IDEs like Eclipse, Visual Studio. A lot of IDEs are Eclipse-based, even aside from Eclipse. So you can look into that. Runtime agents in development, right? This is really Contrast. So full disclosure, Contrast is a spin-off from Aspect Security, right? Started Aspect and then moved. It started its own entity now. So I'm a little biased. I try not to show that bias, but just in case, full disclosure. So, but you can have a runtime agent where the development team, they're doing testing, right? They're doing functional testing of their application to make sure it's working. If it's a web app and they have a local web server on their computer, they can have a tool, an agent, sitting there and watching all the requests and responses and giving them that security feedback in development at the same time. It's pretty valuable. And then any command line tools. I mean, anything that you can just hit go from the command line, developers are pretty smart, right? Like they can run command line stuff. You hit go and you get some results. As long as there aren't a lot of false positives, it's, you can do that. Developers are typically pretty open to it. But low false positive rate is very important. Several other people have said that here. Don't give your developers false positives because they'll lose confidence in you immediately. Then in QA, same thing. You can have a runtime agent. This is the best, right? You take a runtime agent and you stick it in QA. You put it on the server. Your QA team is testing, and you're just getting results. Your QA team is not doing anything different. They're doing the same test they were doing before, but now you're getting security results. It's the same thing if you stick a browser plugin or a proxy there, right? You run Zap. You put Zap on your QA testers' machines or Burp. You put it in passive mode, so it's passively looking for issues. You'll get all the low-hanging fruit. Or do you have the right cookie flag set? And it'll even find in some cases, cross-site scripting or SQL injection, or at least give you a lead. And those things can really save time later when you get to the security testing, because your security testers don't have to look for those things. Right? They're already found in QA, or they're very likely not there because they were fixed in development. So I like to think that by moving security further up and by automating things, you allow your security team at this phase, at the security testing phase, to really use their brain power, to really use their security intelligence, and not to just be, how much time does it take to unzip a huge amount of source code, right? Like that's a waste of time. So there are better ways to handle that. So again, I'll talk about that later. So agile processes, right? Same things. You have development, QA, security testing, it's all the same. Then you have DevOps, which is really interesting. There's lots of things you can do with DevOps, and a lot of people have talked about those so far, so I'm not gonna go too much into them. But they can also run any high confidence test. That's pretty quick, right? Command line tools, anything like that. And then you have continuous integration, right? Continuous integration is awesome. And this is really what I would hope becomes like security's bread and butter moving forward. There's no reason that continuous integration is only used for development. Right? You can do anything in continuous integration. Well, not anything. You can do a lot in continuous integration. Right? You can have runtime agents. So this is what I'd love to see from a security testing point of view. Right? Developer commits code. Continuous integration server senses that, builds the code, runs static analysis on it. Right? Executes whatever static analysis tools you have. You're probably already using PMD and other code quality tools now. So you can write security tools for those. But you can also add hooks. Most of the big name commercial tools have command line interfaces also. Or some of them even have automation interfaces that are totally different. But the command line interfaces are pretty powerful already. So you could probably run most of your static analysis, commercial static analysis tools in continuous integration. And we've done that for different customers. It works out very well. So you get the static analysis results. So then the application is built and VM is started up. This is where your DevOps team comes in. Your DevOps team can help you to manage the deployment of this new build to a testing server, right? You spin up a VM, use Puppet or Chef or whatever you want, spin up this VM, take your newly built web app, push it over to the VM into a running web container, web server on the VM, and then you use Selenium where your dynamic analysis tools get executed via scripts. All happens automatically to dynamically test your applications. Or you run IAST on them. It doesn't matter. You can do any test you want. But now you have your application actually spun up in this VM. And at the end of the tests, you copy the results out and you send them to a reporting console, or you store the XML on a shared drive, or you do whatever you want to do with them. And then you destroy the VM. And the next time you start from scratch, you do the same thing, right? That's what DevOps specializes in, is doing this type of thing for production. They could just as well do it in continuous integration environments for testing. Oh, and then all those results from continuous integration, get fed back to development, right? So anything you find continuous integration is during your build process, is during your development cycles. So you send that back to development, and all that stuff gets fixed right away, instead of waiting until down the line when you get to security testing. So how do you know where to integrate? Where do you make that? How do you make that decision? Well, if you're using continuous integration, if you're doing continuous delivery, I really recommend you start there. There's some upfront work, but it's well worth it because you get the results really fast and all the time. You get them regularly. You can set it to do it on every commit. You could set it to do it on any schedule you want, every day, every week, every month, every quarter. Your developers have time to run scans. Most organizations we've worked with, they don't, right? And developers want to be developing, so having static analysis tools on their laptops usually doesn't work out because it takes a while. But some developers get really jazzed up about this. The ones who are also into security love to run static analysis on their own laptops. So this is kind of a case-by-case basis. You have to evaluate your developers to see if this would be a fit or not. But in some cases it is. Do you have a QA team? Because if you do, your QA team should be doing security testing too. They don't need to know about it, right? You make it transparent to them. But it should be happening because it's earlier in the process. You get those results. You can make changes. And then integrate a test like you're already doing, but try to simplify the workflow a little bit. And I'll talk about some ways to do that in a few slides. So integrate with your existing tools. If you're using, this is Jenkins, or this is part of Jenkins. We had a customer who was using AppScan Source. It's IBM AppScan Source. And so for continuous integration, we wanted to make it really easy. It has a command line tool, right? You can execute it all from the command line. But if you do that, you have to write a bunch of batch scripts or PowerShell scripts or shell scripts, depending on what you're using. It's a lot to maintain. It's really fragile. And we wanted their security team to be able to do all of this, and we don't want them to have the prerequisite of knowing all of these scripting languages. So we built a plugin for Jenkins because it's extensible. Like most tools these days built, or at least open source tools, are pretty extensible. So we built a plugin for Jenkins with a pretty front end where you don't have to do anything. You just, in your application, you add this as a build step. You add the AppScan build step. You stick in your email addresses for notifications, and that's it. If you and you put the files generated by AppScan in the directories there, which is a common directory path structure, right? And that's it. And then when they hit the next build, AppScan Source will run automatically. You get all the output within Jenkins, and you can do whatever you want with that. Results get published to AppScan Source, to AppScan Enterprise console, the reporting console. You can get reports emailed to developers, et cetera. You can do a lot. The point is, try to use the tools you already have, because they're pretty powerful and most of them are extensible. But regardless of where you integrate, provide security feedback as early as possible. I'm sure most of you have seen this chart or charts very similar to it. The cost to fix an issue is way cheaper if you do it while developers are still developing than if you do it during production or any other phase. Automate as much as possible. It'll save you a lot of time. It'll save you a lot of energy. And it'll let people who get into challenging jobs like security do that security work instead of more mundane, redundant tasks. And the more transparent the process, the more likely it'll be accepted, right? Because if you try to go in and say, we have all these new processes we want to do that's going to make security way better, you're going to get a lot of pushback because people have been doing the same jobs for 5, 10, 20 years, right? They don't want to change. It's difficult. So process efficiency, real quick. This is kind of what I was talking about, where if you don't use continuous integration now, or if you do, but you kind of want to stay out of the developer space, this was what we did with one of our customers, where they had each application is basically on its own, right? The applications don't talk together. They all have different build servers. They have different source code repositories. So what we did was we set up a CI server, a Jenkins server, for the security team. And then we said, we need to get access to all of your developer source code repositories. And that was a big undertaking. That's not easy in a large organization, especially if they're using lots of different technologies and permission systems and things like that. But we did it. It took a while, but we did it. And what that does is, so first of all, now you can add all those security tests on the security team CI server, right? And you can test whenever you want because you have access to the source code, you have access to all of their dependencies. So when I was talking about extracting those zip files, what I mean is, as a security consultant, when we go to a company that wants us to do a review, a source code review, they'll usually send us a zip file or an ear file or whatever with all of their code and some of their dependencies, which means that we can't build their application. And that's fine. We're used to it because that's how the industry has been working for a long time. But it would be nice if we could, because we could do other things with it. If you get it to compile within Eclipse, you get all sorts of nice ways to navigate through the code. Otherwise, you end up just searching through files manually. But if we have a CI server, right, and we have access to their source code directly, we just hit build. Suddenly, we have all of their source code and all of their dependencies. We have everything that the developers have. In a lot of cases, you'll also get their build scripts and who knows what else, documentation that you wouldn't have otherwise, because developers store that stuff in their code repositories. So this was a nice solution if you have a pretty decentralized group of development teams. And it really improved the security teams. So when the security team then, in this case, needs to do a security review, they just hit build, they have all the source code, and they can start right from there. They don't even have to reach out to the development teams, right? And less back and forth makes everyone happier. Simplify your workflows. So this is static analysis, or an example at least applicable to static analysis. This is actually at that same organization where their security teams were doing kind of one-off security reviews. And this is very common, right? One-off security reviews. They would get the source code and scan it with this particular tool, with AppScan Source. I said it earlier. So they would scan the tool with AppScan Source, and then send the results to developers, and then they were done, right? But what we said is take the results you have, right? And instead of just sending the results and going through one at a time, if you use the tool as it's intended, right? AppScan Source allows you to bundle findings. Fortify allows you to bucket findings. It's the same thing, right? It's just grouping findings. You put them into these groups, and you put that grouping in a central location. The next time you or someone else goes to review the application, they can grab those groups, and it will show them which findings you've already looked at, right? So year one, you look at all of the findings. Year two, you only have to look at new findings, because all of the findings that you looked at last year haven't changed at all, right? Whether these are false positives, right? You have 10,000 findings, you look at 10,000 of them, presumably, and 9,996 of them are false positives. So you have 4 real vulnerabilities. The next year, you look, do I have these 4 vulnerabilities? Yes or no? And then what's new? What in the code has changed, right? You don't have to look at those all 9,000 again. So general recommendations, if IS is available, if it's a good fit for you, definitely recommend using it. It's a pretty advanced, it's pretty cool technology, and it's worthwhile. If it's not, look for it, keep it on your radar, because it's pretty good. If possible though, it's not a silver bullet, so definitely use at least two technologies, right? So if IS isn't available, you should be doing SAST and DAST, and if it is, then I'd figure out what else is a good fit. I don't really want to make recommendations in general, even though this is called general recommendations, but use at least 2. And when you do, don't create silos in your security teams. So we see this a lot. We go in and they have a SAST team and a DAST team, and the teams don't talk, right? And they use different installations, they use different versions of the software, right? And these vendors, if you buy a tool from these vendors, if you buy a SAST and DAST offering, they usually come with a reporting web content website, whatever. Fortify comes with SSC. AppScan Source comes with AppScan Enterprise. That's where all the findings from both can go. So you can go to one place and look and see all of your findings, right? But most organizations aren't doing it like that. They have their SaaS team that has an installation of this reporting console and a DAS team that has an installation of this reporting console. They don't talk. Their vulnerabilities overlap. And developers get 2 reports every time there's a security review. They get a SaaS report and they get a DAS report instead of just one report that says these are the vulnerabilities correlated, blah blah blah. It's have your teams talk. It's worthwhile. If you're interested in this, prototype, pilot. There are lots of free tools out there. Really like Zap and Burp. They're really good to start with Dast. I really like SonarQube, is great, both as a reporting console. If you haven't used it, it's worthwhile. It's really a code quality tool, but you can do security stuff also. It used to be called Sonar, and they rebranded to SonarQube, which makes Googling for them a lot easier. And then sprinkle security through your SDLC. I like that. Definitely worthwhile. Don't just stick it in one place. And then get continuous, which is a slide I removed. But it's all about continuous application security, which Jeff Williams talks about all the time, right? It'd be really nice if instead of having one-off reports that say, right now my security looks like this, you have a continuous dashboard that shows you right now, not 3 months ago when I did those security reviews, but right now, this is what my security posture looks like. And that's possible if you use a bunch of these tools, you automate them. We call it sensors. It's a whole different talk, but it's worth looking into, continuous application security, and I'd be happy to talk about it more after this if you'd like. And this is my last slide, so I'm wrapping up. If you're still not sure what you want to do, just come talk to me. I'd be happy to talk to you. Email me, contact me in some way. I'd love to talk about this stuff. And you're not alone. Everyone's using these tools, and everyone's having trouble with them. Right? They're very large, complicated, expensive tools. They're not designed for people who even go to you can go to a week-long training and come out, and then when you go to run the tools in your organization, you still have no idea what you're doing, right? That's very common. So you're not alone. It's a real problem, and hopefully through automation, we'll make it a little easier. So if you have questions or positive feedback, I'm open to it. If it's negative feedback, maybe email me, but any questions?
So with validating some of these tools that to see whether they're truly doing the proper findings, like for instance, SonarQube used that in an organization, and one thought was they have those profiles you can add in, and to validate that they're actually catching these things, one thing we wanted to do is like using OAuth WebCode to allow an application that's purposely has all these vulnerabilities, and to see if the tool actually finds all those that you know are in there. If you come across any of that it doesn't have to be just the SaaS stuff.
Yeah, I thought about having a slide in here that kind of had a high-level summary of how well SaaS, DES, and IAST in general work with different vulnerabilities, specifically across the OAuth top 10. I actually have it in here as an appendix slide. I left it out because I don't know if it's 100%. It's mostly anecdotal, actually. There's writing on the bottom, so let me get rid of that. But it's mostly anecdotal, which is my problem. So I don't have a lot of actual data across the tools, but I want to. It's something I'm trying to build right now. But it's definitely a good idea, right? Along those same lines, if you have certain vulnerability types that you're looking to find, right, certain ones that are really important to you, then it's definitely worthwhile to build a test suite and test the tools that you want to run on the test suite, right, before you buy them. Sonar is a great example. You don't have to do that, but that's actually testing your tests if you write Sonar rules, right? And that's a good thing. So I guess the answer is no, but hopefully yes the next time you see me. Yeah. Thank you. Any other questions? No? Well, thank you all very much. Really appreciate you coming.